Welcome to BSc Statistics students. We discuss one more result of correlation. What is the result? If x and y are uncorrelated variables and if u is equal to x plus y and v is equal to x minus y, then obtain the correlation coefficient between u and v. Which means here it was specified that x and y are uncorrelated variables. There is no correlation between x and y, that is r of xy is equal to 0. Now you have to calculate the correlation between u and v, which was specified u is equal to x plus y and v is equal to x minus y. U and v are related with x and y. You have to calculate correlation coefficient between u and v. It is a direct question. It is a very direct question. So one particular result is what specified there in the result. One particular clear indication which was specified that x and y are uncorrelated. So therefore, what I consider if x and y are uncorrelated, I am starting the result. X and y are uncorrelated. X and y are uncorrelated, which means Rxy is equal to 0. That is, which implies covariance of x comma y is 0. Let's you consider simply in this fashion. Rxy is 0, which means covariance of xy is 0, not sigma x and sigma y. Covariance of x, R is covariance of xy by sigma x, sigma y, in which I consider if covariance of xy is 0, then Rxy is 0. Right? So therefore, I consider Rxy is 0, therefore covariance of xy is 0. Whenever in the calculation of correlation coefficient between u and v, if I get some covariance of xy, I consider at 0. I substitute as 0 and so that I calculate the result. Right? So now I start the calculation of the correlation coefficient of u and v. So if we consider Rxy is equal to 0, covariance of xy is equal to 0, then it is specified as two particular variables, u is equal to x plus y and v is equal to x minus y. Then you have to calculate one by one. To calculate correlation coefficient, it is required to calculate variances, covariance. So first of all, variances. Sigma square u, which is nothing but the variance of u, that is expectation of u minus expectation of u the whole square. So is equivalent to be expectation of what is u, x plus y, minus expectation of x plus y the whole square is equivalent to be expectation of so do the expectations of x plus y minus expectation of x minus expectation of y the whole square. Before doing the square, you keep all the terms of x at one particular term and y and another particular term, so that you know it's very clearly why, because we are considering this to have a pattern, a clear pattern. So here it is, you see, these are x minus expectation of x. This is one particular term. And plus y minus expectation of y is another particular term, the whole square. Clear? Now you can take square and by doing do the square and take expectations so that you will get the terms. You see, x minus expectation of x, I am considering a, y minus expectation of y, I am considering b, a plus b whole square. Just do square, that's all, and then take expectations immediately. Same step, and simultaneously you do square and take summation, take expectations. Square and do and take expectations. Okay, do square and take expectations. What do you get? It's nothing but is equal to expectation of x minus expectation of x the whole square. First one. Second one, plus expectation of y minus expectation of y the whole square. Next, plus 2 into expectation of x minus expectation of x into y minus expectation of y. Am I right? So because 2ab term 2 is a constant, I am taking outside. I have explained number of times that expectation of constant into x, expectation of cx is equal to c into expectation of x. That's what I have considered. So 2 I have taken outside and this is the value now. So right, so therefore what is expectation of u? That is sigma square u. What is sigma square u? Expectation of x minus expectation of x whole square. What is this? Variance of x. So it is sigma square x. This is expectation of y minus expectation of y whole square. Sigma square y is variance plus sigma square y. What is this? Covariance of xy. Expectation of x minus expectation of x into y minus expectation of y is a direct formula of covariance of x. Therefore, this is plus 2 into covariance of x comma y. At very first, it was specified that x and y are uncorrelated variables, from which I have considered Rxy 0, from which covariance of xy is also 0. So therefore, this is 0. So that this value is sigma square x plus sigma square y. Right? So what is this sigma square u? Sigma square u is sigma square x plus sigma square y. So one variance we have calculated. Now we calculate sigma square v, variance of v. We start the calculation of variance of v. Now what is v? Sigma square v. What is v? Expectation of x minus y. V minus expectation of v whole square. This is the formula, and in which the v is nothing but x minus y. Expectation of x minus y minus expectation of x minus y the whole square. So is equivalent to be expectation of what I do here. First of all, I take expectations for this. Do the expectations. So x minus y minus of expectation of x minus of expectation of y whole square. Whenever you have in the expectations, you always keep all the terms of x at one particular term and y in another particular term, so that it will be very easy to identify and convert in terms of the formula, the variance, covariance, etc. Right? So therefore, what I am doing here, one more step. I am not doing square. So what I am doing here, x minus expectation of x. You see, I am taking it this particular term, x minus expectation of x. So x minus expectation of x, and I am taking common as minus. So therefore, minus y minus expectation of y. You see, it is very clear. So it is minus y. And this minus of minus plus expectation of y, this so hence minus. If you take common minus as well, so then it is minus expectation of y. So y minus expectation of y with minus. So x minus expectation of x I considered one term, y minus expectation of y another term. Now I am doing square and then take expectations. What you will get? Do square and take expectations. What you will get? Is equivalent to b. Now the first term, expectation of x minus expectation of x the whole square. Clear? B square plus b square term plus expectation of y minus expectation of y the whole square minus 2ab. This is minus 2 into expectation of x minus expectation of x into y minus expectation of y. Right? So 2ab term we have, and 2 is a constant and taken outside, and the remaining value is x minus expectation of x into y minus expectation of y. So this is expectation of x minus expectation of x whole square. This is expectation of y minus expectation of y whole square. This is 2 into expectation of x minus expectation of x into y minus expectation of y. So now the terms, it is very simple to consider here the values which are in terms of formulas clearly, obviously clearly. Right? So this is sigma square x, variance of x. This is sigma square y, the variance of y, minus this is covariance of xy. That's what I explained again. Rxy is 0, covariance of xy is 0. At first we have considered, therefore this is 0. Again the sigma square v is also Sigma square v is also sigma square x plus sigma square y. So both sigma square u and sigma square v also obtained as sigma square x plus sigma square y. Now only the term left is covariance of x comma covariance of u comma v. That's what we have to calculate the correlation coefficient. So now I start the calculation of the correlation, the covariance of u and v. Now I start the calculation for covariance of u comma v. What is covariance of u comma v? Is equivalent to first formula. Expectation of what I consider u minus expectation of u into v minus expectation of v. What I consider this particular formula, the fundamental first formula, is equivalent to v. Now you substitute u is x plus y, v is x minus y. Substitute the values. X plus y minus expectation of x plus y and multiplied by this is x minus y minus expectation of x minus y. This is what we have to do. You have to do the multiplication and then take expectations. Before that, again, what I do, all the terms of x in one as one term and y are one term, right? Here you see here, you take expectations first this. So x plus y minus expectation of x minus expectation of y. This is the first term. And then this one. X minus y minus expectation of x minus expectation of y. Right. Now you consider in the fashion that all the terms of x at a glance at one particular term, and so that what you get x minus expectation of x. This is what we did in the variances as well, plus y minus expectation of y. This is the first term, and here this x minus expectation of x minus I take common minus and y minus expectation of y. Right. So it is now there are two terms, x minus expectation of x and y minus expectation of y. If you multiply and if it takes square, then you will get the terms, 4 terms. If you multiply and takes, if you square, multiply and then take expectations, you will get 4 terms. So a plus b into c plus d, c minus d. You will get 4 terms. Get the 4 terms and take expectations. I am doing simultaneously multiply and take expectations. Here multiply and take expectations. X minus expectation of x into x minus expectation of x whole square. Take expectations. Therefore, it is expectation of x minus expectation of x the whole square. Right? Next, x minus expectation of x and y minus expectation of y with minus sign. So it is minus expectation of x minus expectation of x into y minus expectation of y. First term finish. First term with multiplications finish. Next, y minus expectation of y into x minus expectation of x with plus sign. So therefore this is plus expectation of x minus expectation of x into y minus expectation of y. Next, y minus expectation of y into y minus expectation of y with minus sign. Therefore it is minus expectation of y minus expectation of y the whole square. We have the 4 terms we have on the board, right? So first one is x minus expectation of x into x minus expectation of x whole square. Taking expectation, you will have this expectation of this, and then x minus expectation of x into y minus expectation of y. We multiply and take expectations with minus sign, and then second term y minus expectation of y into x minus expectation of x with plus, taking expectations. And then last one, y minus expectation of y the whole square, minus expectation of y minus expectation of y whole square. So therefore, these are the 4 terms. This is variance of x, this is variance of y, this is covariance of xy, this is also covariance of xy. You see the terms here. Now I write the terms here. So what is the final, we have the terms. This is sigma square x you need not to convert in terms of covariance of xy. Directly you can cancel. This is minus sign, this is plus sign. So you can cancel out. And this is minus sigma square y. That's all. Finish. Clear? This is with minus sign, this is with plus sign. You can cancel out. Whether it is covariance or not, that is not the matter at all. Right? So sigma square x minus sigma square y. This is minus. This is sigma square y. This is sigma square x. The formula. What do you get? Sigma square u and sigma square v. Sigma square x plus sigma square y. So sigma square u is sigma square x plus sigma square y. It is also sigma square v. So therefore, now I calculate correlation coefficient between u and v. That is what required to calculate. So therefore, the correlation coefficient between u and v. Therefore, the correlation coefficient between u and v, RUV is equivalent to v. RUV, which is equivalent to v. Now I consider RUV is equal to covariance of u comma v divided by sigma u sigma v is equivalent to v. What is covariance of uv? Sigma square x minus sigma square y divided by, I consider square root. So sigma u sigma v. Sigma u is equal to square root of sigma square u is equivalent to the square root of sigma square x plus sigma square y. Do you understand this? Sigma square u I have calculated, but in the formula we have sigma u. So sigma u is square root of sigma square u, which is square root of sigma square x plus sigma square y. So that's what I am writing both sigma u sigma v are sigma square x plus sigma square y multiplied by sigma square x plus sigma square y. Therefore, at the end, the final value of RUV. Therefore, RUV is equal to, these are the two particular terms which are same. Square root of a into a. It is nothing but a. A square. Square root of a square. It's a. Right? So therefore, it is sigma square x minus sigma square y divided by sigma square x plus sigma square y. That is the correlation coefficient between u and v. That is what required to calculate. So if you consider x and y are standardized variables, then what is the correlation coefficient between x plus y and x minus y? What is the correlation coefficient between x plus y and x minus y? For which you have considered u and v are two variables, and then we have calculated the correlation coefficient. So we got this value, sigma square x minus sigma square y by sigma square x plus sigma square y. Thank you.